We started a little bit of this before, since some of you asked, I think Charles asked, but anybody else start any of this?
Tried.
Huh?
I tried.
And how'd that go?
One page, and I'm like, there's a lot of words that I don't understand.
One page and you're already lost, huh?
Yep.
Okay, well, hopefully we can make that better. Again, it's only 4 chapters, but there's a lot to it, so we should have plenty of time to get through it. All right. Everybody see that okay? Jesus, classroom. I'm not here. Oh, I know what's wrong. I got the wrong lights turned on. Should have turned this one off. That should be better. All right. Who's heard of a torque converter? Yeah? Yeah? Nobody else has even heard of one? Torque converter.
It's like right at the front of the transmission.
It's what what an automatic transmission uses to connect to the engine. We'll get to that. Purpose, function, operation of it. Purpose, function of lock-up torque converter. 2 different types, okay? Anything probably 81 or newer is going to have, with automatic transmission, is going to have a lock-up torque converter. We'll get to that. Shift modes we'll go through: planetary gear sets, compound planetary gear sets. The whole automatic transmission thing. Okay, so what's the difference between a transmission and a transaxle? Because sometimes you'll see this. What's the difference? Anybody know?
I can tell you what the transmission is. I can't tell you what the transaxle is.
Okay,
Isn't the transaction actually for like front wheel drive cars?
yeah. There you go. If it's front-wheel drive, it's a transaxle. It's actually a transmission, but they call it a transaxle because it's got the rear differential assembly in it because it's a front-wheel drive. That doesn't have drive shaft, rear differential, all that. The differential or final drive assembly is in the transmission. So it's kind of an all-in-one, yeah.
That's when the engine's sideways.
I'm sorry?
That when the engine's like sideways, like front
Yeah,
engine's
uh-huh,
sideways.
yep, uh-huh, yep. Okay. Automatic transmission, transaxle, non-planetary gear sets. Operation servicing of, anybody heard of a CVT, another type of transmission? And then there's a dual clutch automatic. Anybody heard of CVT?
Yeah.
So a transmission that doesn't shut.
What's that?
Isn't that a transmission that doesn't shut? Once you just lower it, it just goes.
Yeah,
just
pretty
stays.
much, yeah, works on
Alright.
a pulley system, yeah. Yeah, so we'll get to CVT, dual clutch automatic. Okay, this is just a little bit of background, and this isn't necessarily important, but history goes back 100 years for automatic transmissions. They've been around for a long time. Almost all of the vehicles now have automatic transmissions in them. Some vehicles they don't even offer with a manual transmission.
I heard back in the 90s that there was only like manual transmissions, like everywhere.
There was a lot more back then. Yeah. Okay. First thing we're going to talk about is the torque converter. Okay? What does that do? And where is it located? Between the engine and transmission, or transaxle. Performs the following functions. Transmits and multiplies engine torque. Acts as a clutch between the engine and transmission or transaxle. Allows slippage to make it possible for the transmission to be engaged even when the vehicle's wheels are stopped. So, anybody driven a car with a manual transmission? What happens if you come to a stop and don't push the clutch in?
It's gonna stall
The engine stalls, right? Okay? Torque converter allows the car to be able to come to a stop with the engine still running. Okay? Provides slippage. Okay?
So you're saying an automatic car, if there was no torque converter, it would just stall every time you stopped because it's no clutch. Okay.
The early lock-up torque converters, when they came out with those, they had a problem with the torque converter clutch solenoid on those, and they would stick. And the torque converter clutch wouldn't release and we came to a stop, the car would stall, it's just like in a manual transmission if you didn't push the clutch in. So, they finally figured that out, but, okay, parts of the torque converter, 3 major parts. The impeller, the turbine, and the stator. Torque converter provides a fluid coupling that allows you to be able to come to a stop with the engine still running, and it provides the cushion between the two.
Another quick question on manual transmission. When you're like first gear and you're going at a low rate of speed, around like 10 to 9 miles an hour, how does the car go up? Like you give it gas and you let go and it goes up. Back and forth. You feel like shit.
In what kind of car?
Like any car. Some cars they do that. When I was at Chevy, usually when I'm just because I'm in the parking lot, so I don't shift really, I just go around. It's just like when you give it gas and you let go and it just goes like, you just feel it, not dying, but it just loses a lot.
In an automatic?
You know, in a manual.
Oh, in a manual?
Yeah.
Oh, yeah. Well, because you don't have any slippage. Because the engine and transmission are directly locked up. So you're gonna get a little bit of that jerky motion in a manual transmission, yeah. Yeah, the torque converter is what takes that away in an automatic. Yep, because you got a hard coupling or hard connection between the engine and transmission on a manual. You don't get the torque multiplication you get with a torque converter either. So typically a car with a manual transmission has a lower rear gear ratio to get the car moving quicker. Okay, because you don't have that torque multiplication with it that you get with a torque converter. Okay, the operation of it. Fluid-only connection between the impeller and the turbine allows for absorption of sudden shocks, speed, and or torque. The stator is located between the impeller and the turbine, multiplies the torque from the impeller. We're going to show you how that works. Torque converter is bolted to the flex plate, otherwise known as a flywheel. Okay, if it's a manual transmission, it's technically called a flywheel. If it's an automatic, it's technically called a flex plate. But you wouldn't be wrong to say it's a flywheel. But that's typically how they separate the two. They're the same thing. So if you had a manual transmission, let's say like this clutch assembly came out of, that's your pressure plate, clutch. This is your flywheel, okay? Where your friction disc or your clutch disc rides right here. This basically doesn't exist anymore. You have a torque converter that takes the place of this, okay? Flex plate kind of looks like this. It's just smaller. It doesn't have this surface for the clutch disc. All it does is provide a place to bolt the crankshaft to the torque converter, and then your ring gear for your starter, right? Okay. Torque converter, flex plate. Bolted to the engine, and the torque converter replaces flywheel and manual transmission vehicle. Torque converter drives the pump. The automatic transmission is going to have a fluid pump, okay? Torque converter drives that. Well, drive shaft generally passes through the converter inside a hollow input shaft or transfer shaft, internally connected to the converter by a spline or hexagon shaped shaft. Okay? Transmission input shaft. Drive transmissions are inline method. They drive the converter, provide a directional connection or mechanical connection between the turbine and the input shaft. Okay, I'm going to go through the operation of the torque converter now. It's basically just a fluid coupling. It's just the way the transmission fluid flows to the torque converter that operates the pieces inside there. Right? There's two types of fluid flow inside the torque converter. One is called rotary and one is called vortex. Rotary flow is created by the rotation of the torque converter. When you start the car, torque converter spins because it's bolted to the engine, right? Okay, that drives the fluid pump, gets everything going inside the transmission. Vortex flow is the flow from the fluid from the impeller to the turbine and then back. And we'll see a few pictures of that. I know there's some in the book as well. Torque multiplication, that occurs whenever the vortex flow makes a full cycle from the impeller to the turbine, through the stator, and then back to the impeller. Now, we'll figure out what the difference between the turbine and impeller is and which one's which and as we go through this, okay? There's a couple of phases of the torque converter. One is a coupling phase. When the speed is 90 degrees or more, the fluid flow in the torque converter is mostly rotary flow. Angle of the flow from the turbine to the stator increases, causing a coupling phase. One of the things you'll hear talked about when you talk about torque converters is stall speed. That is normally what somebody will talk about if they talk about a torque converter, and especially if you change it to maybe something for a performance application, you're going to change the stall speed. The stall speed is determined by the actual outside diameter of the torque converter and the angle of the stator blades. Okay? Stall speed is defined as the speed the speed when the engine drives the impeller at the maximum speed possible without moving the turbine. Normal operation. When the transmission is in park or neutral, some engine torque is transferred to the input shaft of the transmission or transaxle. This is what we were talking about a minute ago. Stall speed is determined by the outside diameter of the torque converter, the angle of its stator blades. Those will determine the stall speed of the torque converter. Vehicle manufacturers, when they select a torque converter for a particular vehicle, they just try to match the powertrain requirements and operating demands of the vehicle. This is just a picture, a cutaway picture of a older transmission used in the 50s. I don't know why they put that there, but they did. Okay. This is the three main parts of the torque converter. This would be what it looked like if you cut it open. Made from three parts. The impeller is located at the transmission end, attached to the housing, and is driven by the engine. The turbine is located on the engine side and is driven by fluid flow from the impeller, drives the input shaft of the transmission. The stator redirects the flow to improve the efficiency and multiply the torque. Now, if this doesn't make any sense, there's going to be another diagram here that's going to help you understand how that works. This isn't the one. This just talks about the split rings that they put in there to improve the efficiency of the torque converter, just reduce turbulence inside the torque converter. Okay, this is a pretty good description of how a torque converter works. So you got, pretend like you got two fans here, okay? One of them is plugged in, right, and it's running, the other one isn't. So this one's going to be blowing air across this fan, right? Even though it's not plugged in, that fan blade is going to turn, isn't it?
Yes.
It's the same thing with a torque converter, only it's fluid. Okay, a fluid flow that causes, this would be bolted to the engine, okay, turning all the time when the engine's running. This is the other connection that creates the power, okay? Transfers it to the input shaft, that would be like the non-powered part. Does that help a little bit, maybe? Sometimes people go, oh, okay, I get it now. When you see the kind of the two fans, one that's powered, one that's not, that kind of tells you what's going on inside the torque converter again, but it's just with fluid flow, not, obviously not air. What's going on there, brother? You okay?
Yeah, I just want to see yours over in parks right here so I can move my car.
You just want to do what now?
See if there's any open parks.
Oh.
So I park like over or on this side of the wall. And I don't know if you can park here or not.
Where, are you over here?
It says
Yeah.
reserved.
You can't even see right here, but you see over here.
You should be all right.
Alright, I'll park right here.
Oh, right down here?
Yeah.
Yeah, that won't be a problem.
Alright.
Yeah, you're good. They won't mess with you over there. Okay, torque converter, Bose tube flex plate attached to the crankshaft, rotates at engine speed, okay? This is supposed to be a flex plate here. Obviously, it's a little sideways drawing. Transmission input shaft goes through the converter. Okay, this is kind of what a torque converter looks like. Obviously, it's not the whole picture. This looks like a giant donut. This is the part that goes into the front of the transmission. These little flat sides right here are what goes into the fluid pump that drives the pump. So anytime the engine's running, the pump is running in the transmission, okay? Just like when you start your car, the oil pump starts turning, right? Feed oil to the engine. This does the same thing. Turns the fluid pump of the transmission, gets the fluid flowing through the transmission. And there would be the front. You see your input shaft, you see your stator support shaft, and then that front seal. This just keeps fluid from leaking out. Nothing exciting there. Same thing any seal would do. This is the input shaft. This is actually what starts to turn when the non-powered side starts to turn. Like if you saw the two fans, right? When you turn that input shaft, starts turning everything inside the transmission. The vehicle will move at that point. All right, this is talking about the torque multiplication phase that occurs when the fluid leaving the turbine strikes the front of the stator blades and is redirected back to the impeller. Okay, your stator. That is going to contain a one-way roller clutch. What that means is it will turn one way and it locks the other way. Okay? It'll only turn one way. Okay? It'll only rotate in one direction. It will allow freely to spin in the opposite direction. Okay. Now that you know everything there is to know about a torque converter, what's the main purpose of it?
Decrease slippage.
To do what now?
To decrease slippage is one of them. I wouldn't say it's the main.
Well, let's see. Anybody got an answer for that besides that? What Artie gave us here?
Transformator and multiplier engine torque.
Perfect. Transmit and supply engine or multiply engine torque. Exactly what it does. Okay. Remember I said that most torque converters now are the lockup style torque converter. That means it's got an extra piece inside of it. It's got friction material. It will eliminate, or doesn't completely eliminate, but reduces slippage when you're driving down the road. Increases your fuel economy a little bit. So what happens in a lockup torque converter, it reduces slippage by using that TCC or torque converter clutch to lock the impeller to the cover or the shell. Eliminating torque converter slippage can improve fuel economy 4 to 5% during freeway cruising. Torque converter clutch is controlled through the powertrain control module or transmission control module, TCM or PCM. Regulates the timing and the application of the clutch. Okay, another torque converter. Remember we just saw the first one was only 3 pieces. You had the impeller, you had the cover, and you had the stator for the turbine. As you can see, a torque converter, a lockup torque converter has a few more pieces. It actually has the friction material here, the piston clutch. All that does is just reduce slippage. These are just different types of friction material inside the torque converter. They can be made of carbon fiber or Kevlar or paper, depending on the manufacturer and how much coefficient of friction is needed. I don't know if this is going to do you much good, but that's a cross-sectional view of a pulse width modulated torque converter clutch. Powertrain control module pulses the solenoid and controls fluid flow. to apply the converter clutch. What is pulse width modulation? What is the PWM? What is that? Anybody know? No?
No.
Your powertrain control module does that with a lot of different engine control systems, where if it doesn't want a particular component to just be on or off all the time, it will pulse it, or what's called basically a on and off, and give it a duty cycle. So it's not necessarily off 100% of the time or on 100% of the time. It can do anything it wants in between there, okay? That's what the purpose of pulse width modulation is. All right. Your automatic transmission or transaxle will include the following shift modes: reverse, neutral, overdrive, drive third, second, first load, depending on the transmission. Some only have a few different selections on the gear shifter, but it will have at least 4 of those probably. Everybody's seen a gear selector before. Believe it or not, they actually have a name for that.
What is it? Because I just keep saying shift knob, knowing it's not a shift knob.
Well, I mean, the knob
Technically it
itself
is,
is,
but,
but
like,
they
the
call
gear
that a prindle, believe it or not.
Prindle?
Because, yeah, because it's like trying to
That
pronounce
makes
that.
sense.
Park, reverse, neutral, drive low.
Okay, I guess that makes
Pretty
sense.
funny, right?
Yeah.
Is low for like snow or something?
Low is basically manual first gear. So, in automatic transmission, let's say this was your car, you could put it in drive, or this basically would be overdrive, because it will allow you to select the highest gear automatically, okay? So if you wanted to put in a manual gear, you could just, okay, depending on the transmission, but this is just manual select ranges. This one, anytime you see a D, that means drive, which means it'll shift itself up to this gear. Okay? So if you were to drive this around in D3, let's say, it's only going to shift to third gear. You're not going to have fourth or fifth gear. But if you just put it in drive, typically it's just have a D. It'll just shift all the way through the gears, as many as it's got.
Is it mostly for like snow driving? So like when you're stuck, you just
No, not necessarily. A lot of times, if you're driving like down a steep hill, you keep from, car from going too fast and keep you from having to ride the brake, you would manually downshift it, and the car would slow down. That way you wouldn't burn the brakes up.
So like when you have a sports car and you could put it in manual and not use the paddle shifters, what's the margin for error?
And there's what?
Like what's the margin for error? Because I know like in a regular manual car, it's like certain stipulations you have to stay within, so you don't mess the transmission up. So like, is it the same with automatic cars? Paddle shifter?
Yeah, a lot of times it won't let you over rev the engine. But if you have an automatic transmission, you put it in manual mode, and you use shifter just to shift it yourself, or use paddle shift, whatever it's got, you're just manually selecting in gear, so you can put it in pretty much any gear you want at any time. But it normally won't let you mess it up.
Okay,
So.
that's what the rev limiter is for.
Yeah, so like if you're going 50 miles an hour, or let's say you're going 60 miles an hour, it's not gonna let you put it in manual first gear, because the engine would rev way too high, cause engine damage. So most of the time, it's protected so that you can't mess it up, but.
Yeah.
This is why. That's your output shaft, and this is your little parking pole, they call it. So when you put your car in park, it locks this tooth here. Locks that gear, the output shaft, and the car won't move. Okay, so you can park your car on a hill, put it in park, and it won't move, right? If you have a manual transmission, you park your car on a hill and you got it in neutral, it's gonna roll right back down, right?
So I got a question. Me and my mom had an argument a couple weeks ago.
Oh,
over
that's
the
good.
e-brake. She said, what's it called? I forgot what she said. She was like, stopping real quick, and she slammed on her e-brake, and if you slam your e-brake and you're getting ready to hit somebody, it's just gonna make you slide more because it's locking your tires up. I mean, yeah, you're gonna have to slow down a little quicker.
that?
Exactly. I told her that's not what it's for. She was like, "Why is it called the emergency brake?" That relieves the pressure from
Okay,
the transmission.
so here's
you're
the
part
deal.
on a slope.
Some people still call it an emergency brake. Typically, it's called a park brake now.
Yeah,
Yeah, okay. So is it a pull handle or is it a
that's
foot?
the one where you have to step down on it and then
Oh,
step back on
Yeah.
it to release
Oh,
it.
yeah, step back to, yeah,
Yeah.
okay. Yeah, not a good idea to do that.
Yeah. So for the e-brake, that's just supposed to relieve like pressure from the transmission. when
All,
you're parked
no,
on a
all,
slope.
all your park brake does is just manually apply the brakes so the car won't roll. That's all it does.
So even if I put, okay, so let's say like this, I'm sitting on a slope, right? If I just, it's like a pretty steep one. If I just put it in park, and when I put it in park, the car like falls back a little bit.
Bad idea.
Exactly. So if I put the e-brake on first and then put it in
That's
park.
how you do it.
Okay, yeah,
exactly
that's what
how
I was
you do it.
explaining to her, and she.
Because if you
had a
have an
problem with
automatic
it.
transmission, that's a good point,
Yeah.
and you park your car on a hill or a steep driveway or something like that, put it in neutral, set the brake, and then put it in park. Otherwise, this little guy right here,
pushing up
and there's
against.
not much to it, is holding the whole weight of that car. And then when you go to take it out of park,
Pulls back.
it's gonna bang hard
Mm-hmm.
because you're trying to release the pressure and the weight of the car on a hill, and you're trying to release this lock from it. And you'll hear it clank, and you can mess that up to where you don't even have park anymore.
Well,
So do it exactly the way he said, okay? You're parking your car on a hill, put it neutral, set the brake, and then put it in park, okay?
You'll
That way,
have to
that
move
parking
the
pole
wheels a certain
isn't
way,
holding the whole
Yes,
weight of the
well,
car.
that's if you're
Okay.
like on a public road, like in a
Just,
driveway.
I've heard
Just
you
depends.
put it
But
in
if you're on a
park,
public road and you're parked on the
and
side,
then
if you're
as long as your foot's on the brake,
on the
you put
right side of the
parking brake
road,
on, and then you
you
let
put
go.
your
That's
wheels
not a bad
to
way to
the
do it.
right side.
You
If you're
can
on the
do
left
that.
side of the road going down.
As long as you still have your foot
If
on the
you're on
brake,
the
the
left
car
side of the road,
hasn't,
it'll be on the
and
left side.
the weight of the car
Since
hasn't
we're in
been put
America,
on that
most of
yet.
the time we're on the
That
right
will
side.
work too, but
Same
the
thing,
best
we're
way
going
to do
down,
it
it'll be on
is
the
put
right
it
side.
neutral, set the
Yep.
brake, and then put it in park. But that works too.
Or if you're
Right.
reversed in the spot, depending on
So
what.
when you put it in park, there's the thing that holds onto the clutch goes down. So like, you know when you put it in park, that gear that's holding
Uh-huh.
does it go down or when you put it in like reverse or anything? Like,
It releases when you take it out of park, yeah, because it locks that output shaft. It's connected to your drive shaft, your drive axles or whatever, if it's front wheel drive, so the car won't move. So that gets released anytime you take it out of park. Otherwise, the car wouldn't move, right?
I always
Okay.
put the parking brake in my car. I'm so used to it. Every time I park. I
Yeah,
close.
yeah, some people do that. Not a bad idea. Okay. Planetary gear sets. They're used in automatic transmissions to obtain different gear ratios. Anybody know how a planetary gear set works? Anybody know the main components of a planetary gear set? You're gonna have to know them, okay? Why do they call it a planetary gear set? Because it's kind of like the planet from the solar system, right? It's got a ring gear, it's got a sun gear, it's got a planet carrier. Your planetary gear set torque flow. The way they do this, achieve different gear ratios, is they hold one part of it and let the others turn. One of them is being called driven, is the input. One of the members that's being held is called the reaction member. One of them is the output. A basic, simple planetary gear set consists of one sun gear, a carrier, and a ring gear. They do have compound planetary gear sets to achieve more gear ratios. This is a basic planetary gear set. It's pretty obvious what's what, right?
Mhm.
Sun gear in the middle, ring gear on the outside, planets on the inside, or the planet carrier, sometimes called pinion. Planet carrier showing. The planet carrier which supports all of the pinion gears, also called planet pinion gears. So you can achieve different gear ratios just with a single planetary gear set like that. So they're going to show you what's being done in each one of these, and there's probably a little animation for some of these, I believe. Maximum reduction can be achieved by using the sun gear as the input, holding the ring gear, using the planet carrier as the output. That may not make any sense, but maybe it will after we see some more of this. Okay. So what's going on here? They're using the sun gear as the input. The ring gear is not moving, so there's a device in the transmission that will hold that, okay? And then the planet carrier is your output. That will give you a 4-to-1 gear ratio. That's gear reduction, all right? You can see the math there, right? 4-to-1 gear reduction. That would be like a first gear. Minimum reduction will be achieved by using the ring gear as the input, holding the sun gear, and using the planet carrier as the output. And they're going to probably show you that in action as well.
Bless you.
So all they do is they hold one of them and let the other two do their job. One becomes the reaction member, one becomes the output. And in that case, you would have a 1.33 to 1 gear reduction. How does your car go into reverse? Well, that's how they do it. Reverse can be achieved by using the sun gear as the input, holding the planet carrier, and using the ring gear as the output. And as you'll see in the animation here in a minute, that ring gear is going to turn the opposite way that it did before. Reverse is always gear reduction. You notice you can't go very fast in reverse. I don't know how many people have tried to go over 10 miles an hour in reverse. Car will probably only go 15 miles an hour in reverse.
It makes a whining noise.
Yep, because it's a low gear reduction, and a lot of times the way the gears are cut will cause it to whine, but that's normal. Okay?
Does it do any damage to it if you're going like pretty fast backwards?
I don't know why you would want to do that, but no, it's not going to hurt anything.
What if I'm in a demolition derby?
Yeah,
So
exactly.
I hit somebody with
You're
the
like
back of my
lower
car.
backwards and you just whip it around.
Yeah. Yep. Okay. What are the three main parts of a simple planetary gear set?
The sun, the rings, and the planets.
Right? Sun gear, ring gear, planet pinions. All right. Now we're going to get into the complex or compound planetary gear sets. It's just basically another planetary gear set in front of the other one or whatever, right? There's different types. The Simpson gear set is 2 simple planetary gear sets. The Ravenel gear set, and then you got the Lepelletier gear set. This describes how they work. The Ravenel has 2 sun gears, 2 planet pinions, and a single ring gear. Obviously, these were named after the people that came up with them, like most things are, right?
Yep. Homer Simpson.
If Terrence came up with his own planetary gear set, they'd call it a Terrence planetary gear set.
Yeah.
or whatever, right? Or maybe they typically use your last name, but. Okay. This is your simple Simpson planetary gear set composed of 2 ring gears, 2 planet carriers, and they share the same sun gear in the middle. They do that to get you more than 3 speed. Normal, old school automatic transmissions, when they first came out, they only had 2 or 3 forward gears.
This isn't completely important, it's really off topic, but do you know when we get our CPR and first aid cards?
David's here today, I can ask him, yeah.
Don't we get cards for those?
Yeah, you do, uh-huh, yep.
When do we get them?
Good question, I'll ask David, he's here today. He's actually, substituting for, Deborah for phlebotomy.
Will he be teaching us other things?
Nope,
No,
you guys are
that's
done
it.
with him,
All right.
okay? All right. This is Mr. Revenue's gear set that he came up with. It's composed of 2 Sun gears, 1 Planet Carrier, supports 2 sets of pinion gears with a single ring gear. Now, you're not gonna have to identify these components, but you will have to know a little bit about them, okay? We're probably not gonna show you a picture of that and have you identify every little piece, because it's just not necessary, okay? You don't have to know every little thing, you just have to know about the basic operation, how a transmission works, okay? So don't let it be too scary, all right? Okay, we talked about transaxles for a minute, and I told you that a transmission or a transaxle includes the differential assembly, sometimes called the final drive unit, as well as a planetary gear set that a regular automatic transmission will have, okay? You guys know the difference in the configurations between front-wheel drive and rear-wheel drive, right? Yeah, basically.
So, Transaxle always use, differential.
Yeah, the transaxle is used on a front-wheel drive car. In a front-wheel drive car, the engine's mounted transverse, right, sideways in the car. It's pretty common, right? Okay, so there is no drive shaft, there is no rear differential to put the power to the back tires. Older cars, or anything rear-wheel drive, was all powered by the rear tires, right? Front-wheel drive became really popular in mid-80s. And then, so there's tons of front-wheel drive cars out there, but they run a transaxle. But since there's no rear differential and drive shaft, they put that rear differential assembly and then axle shafts right in the transaxle itself. So it's powered, the car is actually getting pulled down the road because it's driven off the front wheels, right? Older cars or rear-wheel drive cars, whatever it is, they still make rear-wheel drive cars, but you're actually, and you probably don't think about this much, but the car's actually pushing you down the road. In a front-wheel drive car, it's pulling you. You don't really feel the difference, but okay, depends on which set of drive wheels is actually powering the car. And there is obviously all-wheel drive, which powers all 4 wheels.
The power difference between front-wheel drive and rear-wheel drive?
Is there power differences?
No, it's the rear-wheel drive just pushes you more than the front-wheel drive, right?
Typically, the higher powered cars are rear-wheel drive, yeah. They do make some pretty fast
They're more
front-wheel
scary.
drive cars, so.
They're more scary too.
Are they?
No, because when I was driving a rear-wheel drive car in the rain with my dad's truck, I was trying to open
Yeah.
usually when I floor it in my car, it spins a little and it goes.
Mm-hmm.
My dad's truck, I was trying to, this person in front of me was going so slow.
Mm-hmm.
So I just switched lanes, I kind of floored it a little. The truck got sideways with
You
the
bet it
traction
will.
control cut up. I was like, damn, I was scared. He even
Why,
warned me.
why is that?
Because the rear wheels, they're spinning at high speed.
Mm-hmm.
Right?
But
They just get
why
sideways.
is it different?
It's real.
You're right, but what I'm getting at is what's the difference?
It's the way distribution towards the back end, when you slide out, it just spins you.
So think about this, on a front-wheel drive car, you got the engine and the transaxle right on the front wheels, right? All the weight is on the front wheels, so you better traction, right? In a rear-wheel drive, you got the drive shaft and the rear differential, it's lighter in the back, doesn't get quite as good a traction, so it's gonna cause you to do a little more sliding and a little more drift and fun if you like to do that, like he does in his Camaro, if he ever gets it back.
Isn't it better to like lose control in the rear wheel than a front wheel?
Mhm.
It's easier to.
Mhm.
Yeah, it's easier to control.
Yep, they're a lot more fun to drive though.
It was fun when I had it.
Yeah, yeah. It'll teach you how to correct in a slide really quick if you're driving a
I
real
learned
drive
that.
car.
You're not
So
supposed to.
you always turn into it. You're sliding this way, you turn right. You're sliding this way.
Turn
you
the
turn-
opposite way, so
Yeah,
like if you're
right.
going this
So
way,
it'll
you're
correct
trying
it,
to like
yeah.
this
But
way.
don't go too far because you can't overcorrect and then you're doing this.
Yeah.
I did something similar one time. My car's all-wheel drive. I was I was going to school when I was in high school. Obviously, I was hitting this left turn on my street,
Mm-hmm.
and I don't know why. Like my car just felt like it was going a little slow, and it just finished raining, so like the gutter was wet, and I hit into it, and I'm turning, and as I'm going, it like switched gears and started going a little faster,
Mm-hmm.
and I slid off like this is a wall right here. This is a wall over here. I'm over here. I'm going this way. I'm turning, and then it like spins out. I caught myself. I hit the e-brake, and I was like real close to the wall.
Oh, wow.
I almost went on the curb. Like it was like
You saved
real
it, huh?
close. Yeah. It's
And
hard
then
to
you're
save
like,
an
yeah,
all-wheel
I'm a
drive.
driver.
Nah, hell no. I didn't think that.
I'll take it.
Yeah, I'm a driver.
I recovered from the spin out.
I did. I was proud of myself.
Of course, you always are.
Always fun sometimes.
Yeah. I did that one time by accident. I was driving down the road, and this car was pretty new to me. It was a brand new car. I only had it maybe a few months, okay? So car only had probably, I don't know, a couple hundred miles, maybe 1,000 miles on a brand new car. I'm driving down the road, and for some reason, I get this stupid idea that I'm gonna do a real quick lane change, right? Well, the whole car came around, and I'm facing oncoming traffic, and the car just kind of slides off to the side of the road, just parks itself right on the curb. Didn't hurt nothing, didn't hit anybody. I went, oh, that's pretty cool. Like I did that on purpose. I mean, it didn't hurt the car, didn't even scuff the wheels up, nothing, just parked itself right on the curb, facing oncoming traffic.
Damn.
That could have been a disaster.
Yeah.
That's one thing you learn about real cars. Don't switch lanes quick.
Yeah,
Switch
yeah. You should never do an evasive lane change, because chances are you could be in big trouble. Okay, as we talked about a minute ago, your transaxle will have the differential assembly in it, as well as planetary gear set. It uses that. Sometimes it's called a final drive. It's part of the transaxle. That assembly connects the output from the gear sets to the drive axles. As you know, you have CV axles or drive axle shafts on a front wheel drive car, right? Heard of CV joints or CV axles or whatever?
Yeah.
Yeah, front wheel drive cars are gonna have those, okay? We do a whole lesson on those too. So if you had a transaxle, it kind of looks like this. You still have your torque converter, but a normal transmission, it would just come out like this, okay? Transaxle is going to be all this way. And then you got your drive axle shafts that come out the sides to your two front wheels. Another type of transaxle uses a chain to transfer engine torque to the output gear sets for the final drive assembly. If you're familiar with what a rear differential or differential at all looks like, it kind of looks like that, but that's what one looks like inside of a transaxle.
So what's the point of getting a welded diff? I forget. Like for like drift cars and stuff.
It takes the different. It becomes not a differential anymore. It becomes a positive traction, meaning when you go around the corner, one wheel won't turn faster than the other one to allow you to go around the corner. It's just going to slide.
Okay.
Okay. The purpose of a differential is so you can go around a corner. Just think about this. If this was your car, right? You're going around the corner. The outside wheels are turning faster than the inside wheels, right? Because they have a farther distance to travel. So if you didn't have a differential assembly and both wheels turned at the same time all the time, you go around the corner and the car would just start sliding, even on dry pavement.
Okay.
Got to have a differential assembly. Every car has it, whether it's front wheel drive or rear wheel drive. Okay.
Even if you're doing the burnout, it's just you see one wheel spinning and the other one not even moving.
Okay, in that case, what you've got is a differential that is what they call an open differential, which means all the power is transferred to basically the one, with typically the right rear. Okay, if you have any type of positive traction or limited slip differential, it's going to transfer the power to both wheels. You do a burnout, it's going to leave two black marks, right? If you have an open differential, it's just going to leave one stripe on the road, right rear tire. okay? Okay, just like everything we go through in here, there's not just one way to do something, right? They do have automatic transmissions that do not use planetary gear sets. Honda and Saturn use an automatic transmission with no planetary gear sets. These hydraulic clutches inside synchronizers to make shifts between the gears. There's typical non-planetary gear set in the Honda. Has helical cut gears instead of planetary gears. Hydraulically applied clutches commanded by the PCM. Fluid controlled through shift solenoids, which is normal with the automatic transmission. Most automatic transmissions are electronically shifted now. In fact, all of them are, probably for the last 30, 40 years. 30 years anyway.
I don't know who invents these fucking things. They're smart.
What's that?
So I don't know who invents these things, but they're smart, because that's confusing as hell.
Don't like that?
No, that one looks odd.
Okay. Now we're gonna get into the CVT for a minute. CVT stands for what?
It's variable, some variable transmission.
Come on, CVT.
It's right in front of you.
Is it?
Okay,
Oh,
continuous
shit.
variable transmission. Just like Nashville was talking about earlier, right? They don't really shift gears, they kind of just, they work off of a pulley system. So what happens is, one gets bigger, one gets smaller, and as it does, it changes the gear ratio. So that's why they call it continuously variable. Uses two variable width pulleys, sometimes called variators, to change gear ratio from about 2.5 to 1 when you first take off to about 0.5 to 1. Just so you know, anything less than 1 to 1 is overdrive, okay? This is gear reduction, this is overdrive, okay? Normally in automatic transmission, let's say you have a car with a older 4-speed automatic transmission. Like I said, automatic transmission, when they first came out, there were only 2 or 3 speeds, okay? You know, the best you could get was a 1-to-1 gear ratio, that was third gear. Cars didn't go all that fast back then because there was no overdrive, right? Okay? So let's say your third gear was 1-to-1. If you have an overdrive, let's say you have a 0.71 overdrive, then you have another gear, and the car will go faster without the engine working so hard. That's why the transmissions have multiple gears now. They have 10-speed automatics now. Which transmission does your Camaro have? Is it a
6-speed?
A 6? Yeah, yeah. They do have a 10 now.
Oh, yeah, that's the one, I'm pretty
Yeah. Okay, purpose of that, allow the engine to operate in the range where it's most efficient. Every transmission does that though. It allows the engine to operate in its power band where the engine is most efficient. Gives you the most power and most fuel economy. Unless you got a really heavy foot, then your fuel economy is gonna suffer. Okay. In your CVT, you have 2 pulleys that are moved at the same time. One pulley is made smaller, while at the same time the other one is enlarged. The chain is pushed rather than pulled through the pulleys. This is made of hundreds of individual steel elements. Transmission has a total of 4 parallel shafts. Input shaft, drive pulley shaft, driven pulley shaft, and a secondary gear shaft. And we're going to see how it works here in a minute, so there's a little animation, it's pretty cool. Normally you only see a CVT transmission in a smaller car that doesn't have much power, because those transmissions don't like to put up with a lot of power. You're not going to see a CVT transmission in something rear-wheel drive that has a lot of horsepower. Just not going to happen. It won't put up with it.
They have it in a lot of these songs.
Yeah, in smaller cars, yeah. Okay, the pulleys can design can vary by varying hydraulic pressure applied to them. Each pulley has a movable face and a fixed face. We'll see how it works in a minute. Movable face for each pulley is attached to a piston that has a hydraulic control pressure applied to it. multiple disc clutch used for forward and reverse. Some will use a start clutch instead of a torque converter. Servicing a CVT, pressure stall test, start clutch calibration, fluid level, yeah, we'll get to that. Okay, so this looks kind of like a plastic toy or something, right? They're weird transmissions, but that's kind of how they work. We'll get a better picture here in a minute. Okay. So how do they make those change size? Did you see how it started out? You see your input and your output? Look at the gear ratios as it's doing it, right? Your starting gear ratio is 2.1, ending in 0.5 to 1. How does one get bigger and one get smaller? How do they do that?
One side turns faster than the other.
What's that?
The output turns faster than the input.
Okay, it will as it changes gear ratios, but how does one get bigger and one get smaller? How do they make it do that?
Is that where it's like different like sizes going down type thing? Or it's like
Okay.
a spindle almost?
Okay,
So it spins one way.
let's see. Oh, that's not it. Okay, there you go. So, you got a fixed face and a movable face. So, hydraulic pressure here, as it pushes this, it makes it get bigger or smaller. So it doesn't actually change positions. It just pushes this in or out to make this bigger or smaller.
Okay. So hydraulic pressure.
Yep.
Gotcha.
Belt construction, we don't really care too much about. I don't know that's gonna be much good. Sometimes CVT will use a start clutch instead of a torque converter. That's a picture of one.
It's got a little turbine on
Yep. All right. On the CVT transmission, they're just showing you inputs and outputs. So as you know, there's inputs and outputs for every control module for everything your car does, right? So this would be your transmission control module, TCM, okay? Inputs, this is all the information it gets from sensors, and this is what it does. We've talked about that before. That's how computers work too, okay? That's how we work too, right? We get inputs, we process it, and then we decide what to do about it. Okay, that's kind of how that works. Okay, another type of automatic transmission is a dual clutch. Uses a manual type transmission and two clutches that engage either the main input shaft or the counter shaft to achieve the same function as an automatic transmission. Called the dual clutch automatic. They do improve fuel economy a little bit, reduce the cost of the assembly by using manual transmission components, improve the speed of gear changes, and provide a smooth operation. They will use two clutches that are mounted together concentrically. The large clutch drives the odd number of gears, small clutch drives the even number of gears. You gotta remember those, okay? One of them will do the odd, one of them will do the even, okay? You'll see that later. Possibly show up on a test. It could happen. Dual dry, dual wet, there are two types. Could have a dual wet clutch, dual dry clutch. Smaller clutch drives the even numbers, as we talked about before. Larger one, the odd numbers. So in this case, this is what? First, third, fifth, and seventh, and then second, fourth, and sixth. So this would obviously be a 7-speed dual clutch automatic. Advantage of the dual clutch transmission: quicker throttle response, instant gear changes, improved fuel economy. Disadvantages: well, doesn't have a torque converter, so guess what? No torque multiplication. Not as efficient as a CVT, but who cares? Okay, dual clutch automatic is the best feature of an automatic transmission without the power loss of a torque converter. Pretty good design. It's basically a manual transmission that works like an automatic. Dual clutch automatic transaxle uses 2 dry clutches, larger one for the odd numbers, smaller one for the even. In this case, this is a 6-speed transaxle. Advantages, we went through that already. So these are just animations that show power flow through certain types of transmissions. Let's go back through this one for a second. So that transmission they were just showing you, I know you probably didn't see that. That was a 4L60E. Transmissions are typically described by a few different things. So we're going to use that as an example. What would a 4L60E transmission be? This is how many gears it has. It's a 4-speed. Okay? What's the L? What's that? Negative.
Liter?
That means it's longitudinally mounted, meaning it's rear-wheel drive. This is basically the size of the input drum, 60 millimeter. This is basically how much torque can it handle. Okay, they do make a 4L80, which is a little bit stronger, right? E just means electronically shifted. Okay, so let's say this was a 4T60E. Same transmission, only it's now it's a transverse because it's transverse mounted. Okay.
Is it true that most 4-cylinders are front-wheel drive?
I'm sorry.
Is it true that most 4-cylinders are front-wheel drive?
Yeah, for the most part, yeah. Not all of them, though. You can get 4-cylinder cars in rear-wheel drive. You can get a Mustang, Camaro, a lot of rear-wheel drive 4-cylinder cars. You ever drive a turbo 4-cylinder Camaro?
Nah, I wanted to.
They actually run really good.
How are different ones Chevy for a test drive?
Yeah, they run really good. That little 2-liter turbo in the Camaro. Surprise you for a 4-cylinder. Okay, we don't have to go through all of this because it's just going to be confusing. Okay. You don't have to know exactly how to rebuild a transmission, but again, basics is all we need to get you through. I guess I'll put one here in case she ever comes back to class, which I'm not really sure how that's going to work out for her. How we doing? Still working? Everybody done?
Yeah.
Time to go. Okay, let's do it. Let's do it.
Technician A says the gears in the planetary gear set are in constant mesh. Technician B says planetary gear sets have a ring and piston and pinion gear. Which technician is correct? Is it C?
Both of them?
C or B?
What everybody get?
What does constant mesh mean?
Exactly. Glad you asked.
Like they're all smashed together?
Yeah, all the time. Okay, so let's find our picture of our planetary gear set right here on whatever page. Let's just use 1682 at the top, one of those, whatever. Are those gears constantly meshed with each other, meaning the gears are meshed, the gears, are they constantly meshed with each other?
Yes.
Yep.
So it's
They are.
both.
So it's both?
Yep, it is
Oh
both.
man, I thought I was wrong.
It is both. I know sometimes it's scary, huh? I had the right answer, but you made it sound like I didn't.
Yeah. Oh, next.
Yep.
Technician A says that one planetary gear set can provide gear reduction, overdrive, and reverse. Technician B says that most transmissions today use compound multiple planetary gear sets. Which technician is correct? Yeah? No. Both?
Both? Can one planetary gear set provide a gear reduction for takeoff, overdrive, and reverse on it?
Yeah.
Sure it can. Do most transmissions have multiple planetary gear sets because they have lots of extra gears? Gotta have planetary gear sets for extra gears. Okay, they're both right.
Question 3, automatic trans also include differential assembly, C.
Yep.
Yes.
If it's a transaxle, that is a differential assembly, yes. Course 3 should be C.
Brian, which of these conditions is work on very clutch and days? I put during C, during acceleration and highway speed, because it says it engages at high speeds.
Okay, so let's look at
I was looking at,
let's look at 1685, shall we? Where is it? Where is it? Where
I
is
was
it?
looking at 16, like 79,
How come we're close?
like that, in the bottom, right, all the way.
I think it's A.
It says, this says, see the multiple sort.
How come I don't see the, what page are you on?
Page, 1679.
1679, huh?
1679.
All right.
Look at the bottom right corner.
Okay, you should be on 1680 actually for torque converter clutch, or lockup torque converter.
Yeah, it's A. Don't say
Answer is what?
A.
Yeah, it is. It is. Typically it speeds over 25 miles per hour. Now it will disengage if you accelerate, or disengage if you brake possibly. But typically it will not engage under 25 miles per hour. So A is our answer.
Number 5, using a torque converter smaller than the stock size could result in A, smaller than normal acceleration.
A?
Yeah.
Okay. Where did you find that?
On
Oh, you just guessed?
I got D.
It's actually all of the others. It's actually all of the others, except
B
for
and C.
A. So that would be D.
D, yeah.
Faster than normal acceleration and not as good a fuel economy. Remember, the stall speed and torque converter is depending on the outside diameter of the angle of the stator blades. If the converter is smaller, is going to have a higher stall speed, more slip, but it'll give you faster acceleration.
CVT changes gear ratios by changing the diameter of seat.
Drive and driven pulleys, yes, sir.
The torque converter clutch increases efficiency by, is it C? Or no, not C, B.
Eliminate converter slippage. All right.
Technician A says automatic transmissions can shift gears without requiring an interruption of power flow. Technician B says automatic transmissions use synchronizers instead of planetary gear sets. Which technician is correct?
A.
They can shift gears without requiring interruption of power flow. Now, you know in a manual transmission, you have an interruption of power flow every time you change gears, right? Because you gotta let off the gas, push the clutch in, shift it, automatic, no interruption in power flow.
I heard you could double clutch to make it better.
You can.
Like how they do it in Fast and Furious, they just did.
Yeah, yeah, yeah. Be careful what you watch on TV.
Okay, question 9, two technicians are discussing automatic transmission. Technician A says that it's normal for a vehicle to move straight when the gear selector is at a drive position with a brake release. Technician B says that the stator may be defective if the vehicle moves while the gear when the engine is at idle. I think both C.
Okay. If you get in your car and start it up and put it in drive and let your foot off the brake, what's gonna happen?
It's gonna roll off.
Car's
because
gonna
I-
take off, right? Supposed to do that. This guy says it's normal for the vehicle to move slightly when it's in drive and you release the brake. So we know A is right.
Yeah.
B says it's not supposed to do that. He says the steady's defective if it moves while it's in gear at idle speed. Obviously, he is wrong. A is correct, B is wrong. He says it's not supposed to do that. It is supposed to do that. And the lockup portion or function of the lockup part of the torque converter, what does that do?
A.
Same thing we talked about in the other question. Yep, eliminate slippage, improves fuel economy. And let's see what we got for this next one. Okay, let's go through number 1. Which planetary gear set commonly found in a 6-speed transmission?
Is it C? No.
Simpson.
Well, let's see.
It's 1684.
No.
Is it D?
Is it D? Yes, it is D. Okay.
No, yep, I see it.
The Lepelete. Which compound planetary gear set is used in front of the Ravenel? The same one. Okay. Number 3, let's see what we got here. Technician A says converter speed ratio is a measure of coupling efficiency. The other guy says torque converter speed ratio is calculated by dividing the speed of the turbine rotation by the speed of the pump rotation.
Both?
Well, that was a good guess, if it was a guess.
That was a guess.
Yeah, oh. Even the most efficient torque converter has a slippage rate of how much?
Wasn't it 36?
8 to 12.
8 to 12, good. That is correct. Remember I told you about where you're gonna have to know which clutches do what in a dual clutch transmission? This guy says one clutch is used for first, second, third, and the other for fourth, fifth, and sixth.
Isn't that on that last page? Well, the larger clutch drives the odd number gears, and the smaller clutch drives the even numbers.
Exactly. Incorrect statement. Torque converters use the stator as a what?
Stator pump. No. Shoot.
Driven number.
Reactor.
Reaction member.
So it's B.
Yep. All right. Technician A says the held member is also called the reaction member. Technician B says if any two elements are locked together, then the output will be 1-to-1.
B is right.
Okay. Is the held member also called the reaction member?
Not sure.
Yeah.
Mm-hmm. Okay, we did that question already. Torque converter clutch increase efficiency by. I'm making first up because we did that one. And we did that purpose function of the lockup part of the torque converter we did. Alright.
Can we see like a video of how all this stuff works?
Absolutely we can. So while we're on break, I'll run through some, see if I can find some good ones for you. So, let's go ahead and take a break now, and I'll find some videos, we'll watch some of those and get back to this stuff. So, see you about 5 after.